Hello, all of you watching this recording right now. Hopefully you watched the basics of Java recording, and now we are going to talk about robot code. So this is basically taking what we learned in the basics of Java, and we're applying it to the robot and how we code it and how we make each mechanism and how we code the mechanisms. Okay, so we're just gonna quickly recap a few concepts from Java because a lot of those concepts are applied in the robot code. So hopefully it's kind of like a warm up. So remember how we learned about methods? So essentially what methods are is a block of code that only runs when called. And that's kind of like the standard definition of method. But what it means is that we, inside this block, this method here, we basically write the code that we want to run. So we kind of list steps of what we want to happen when we want and what we want the method to do, right? So in this case, we want this method to add the numbers 10 and 20 and then print out the result, right? So once we've created this method and we've written it down, it's not going to work, or it's not going to actually do what we want it to do unless we call it. So that's kind of like telling it to activate now instead of at a different time, right? So we're kind of telling it to add when we want it to. So that's what we mean by when called. And then the block of code that runs is whatever's inside like these brackets over here. So it's basically this print statement here. And we also talked about all these different parts of making a method, right? So this is the modifier, which basically talks about the access level of the method. And we also declared it as static. So yeah, we kind of explained that before, but static basically means that the method, when it's static, it's connected to the class and not the object itself. And then we also talked about the return type. So what we want the method to return specifically. Remember how we talked about it can return things like doubles or integers or Booleans, but it can also return nothing, which is what we call void. And then we also talked about the method name, right? So that's basically what the method is called. And that can pretty much be called anything. There are a few limitations to that, but usually anything. So that's basically the method header that we talked about. And calling methods and using methods is going to be pretty helpful in the future. So something important is that printing and, in a method, there's also two parts. So once you have your header written, you're going to have your parameters here and then your return statement, right? So the parameters are essentially variables that you want to take inside your method so that you can use them. Right, so it's basically passing information, and then the return statement is doing an action and then returning output, right? So let's say we'll give an example. Let's say we want to calculate the area of a rectangle that has a dimension 7 and 5, right? So we would put 7 in the parentheses as the length and 5 as the width, right? So these are basically just standing as placeholders for the two numbers that we're going to use, length and width. So now we have L as 7 and W as 5, I think I said. So then the method is going to calculate the area, which is basically 7 times 5 is 35, and it's going to return 35. Right, so that's basically methods, return statements, and parameters. So then calling the method. We would call it by just simply saying get area, which is the name of the method. If you go back here, you can see we named our method get area. And then in the parentheses, we're going to put our two parameters, right, which stand for length and width, right? We're going to input numbers for those placeholders. So then the method is going to calculate the area of this rectangle, so 10 times 2, and it's going to return 20. Okay, next, we're going to talk about classes now, right? So classes essentially have a certain structure, right? So in the previous video, we talked about the structure of a rectangle class, right? It has its fields up here all the way at the top, which are essentially variables of the class. Then it moves into the constructor, which is similar. It is a special type of method. So it starts public and then the name of the class. And then we input our parameters, which again are just placeholders for specific numbers, right? And then we have our method, which we call in this case get perimeter because that's what we want to happen, right? And essentially just calculates the perimeter and returns it. So now that we have our class, how can we use it, right? We use it by making objects, and we can see an example of a rectangle object here, right? So we create our object by saying class name, which is in this case is rectangle, object name, which we're calling rect1 equals new class name. Yeah. Okay, so now we're going to talk about how we can use these classes specifically. So let's say we wanted to create a rectangle with side lengths 3 and 4. We would basically write the class name, or this example is a little different from this one up here, so we'll talk about this one. So we're essentially going to say the class name, object name equals new, and then the class name again, which is rectangle, and then in here we're going to put our parameters. So this rectangle here is essentially a rectangle that has the dimensions 5 by 10, and we know that because we're inputting them as parameters, right? So 5 is the length, and then 10 is the width. And this is kind of the same thing. We're making an object, another object. And then using methods on our object specifically is really important because that's essentially what we're talking about today. So now that we've made our rectangle object, we can now use the method, right? So rectangle1 is the name of the object, and then we're calling the method. So we're essentially saying rect1.getParameter. And what this does is that it gets the parameter of rectangle1 specifically. And if we made another rectangle, we can also call getParameter on that, and it'll return the specific parameter of that rectangle. Okay, so now that we've kind of learned all the Java basics, we're going to connect what we've learned in Java to talk about how we code for the different parts of the robot. So today we're basically talking about the API, robot parts, and commands. And if you don't know what those mean, just sit tight. We're going to talk about them now. So what is an API and how can we use it? So API stands for Advanced Programming Interface, which is not too important. What you need to know is that it's a collection of tools to build software, right? So it basically lists out all the methods and the classes that we need to use to code for certain objects or certain mechanisms, certain robot parts, right? So there are many APIs that we use. We kind of use a whole collection, but the two main ones I'd say are Rev Robotics and the first API, which is made specifically for FRC, the competition that we're participating in. So we're kind of going to talk mainly about the first API today. And it contains classes and robot parts, classes for each robot part and constructors and methods we can use. So if we take a quick look at the API we're going to use, right, you can see there's kind of like a bunch of packages that we can use, and we kind of click through. And if we just click on this one, we can see all the different robot parts, right? So I'm trying to find something that you guys would recognize. But later on, we're going to talk about the double solenoid, which basically controls the piston. And we also, you guys probably are familiar with joysticks, although it might not be the same definition you have in your head. So it basically has all the different parts that we would need to code for. And then we're going to dive deeper into this in a second. So it's basically a collection of tools. It's kind of like a documentation or a reference sheet, essentially is how I use it. So if I don't know what method I need to use specifically to do a certain action, I would just refer to that API. So this is an overview, which I kind of just showed. Okay, so in order to use the API first, we would need to import. So I don't know if you guys remember from last time with the scanner class, which is basically user input, which allowed us to ask a question to the user and have them input a number or a string or something, and then we take that input and do something with it, right? It's kind of the same thing here, right? So let's say we wanted to use the joystick class, which is one of the robot parts we're going to be talking about next. So to use the joystick class, we have to go to this API here and find the joystick class, and then find this line over here, which will tell us how we need to write the import statement, right? So at the top of our code, remember, we need to import all the packages that we use, right? Because once they're imported, we can now use everything that's coded inside that package or class, right? So we don't have to code it ourselves. We just need to import it so that we can use it. It's kind of giving us access to whatever we need to use, right? So I'm just going to quickly find the joystick class, right? So I'm in this package here. If I just Control F, I can search for joystick. And then here we go. So now I'm at my joystick class. And what you see up here is essentially what the picture has shown me, right? So I'm going to import the statement here. So what I'm going to do at the top of my code, I'm going to write import, and then I'm going to write the statement here, and I'm going to have a semicolon. Okay, so now we're going to talk about robot parts. Now that we kind of have the API down, and just keep the API open because we will continue to kind of reference it throughout all of our code. Okay, so first we're going to talk about the RoboRio, which we call as the brain of the robot. So what it essentially does is that it stores and executes our code. So whenever we want our code to run, we would have to load the code, we would have to build it, and then deploy it out to our RoboRio. And then it'll allow us to run the code. So that's kind of like the basis and the start. So whenever we want to test our code, we kind of build it and then deploy it, and then it kind of like executes in the robot. So essentially the brain of the robot. We kind of give it instructions, and then it does a certain action. So next we're going to talk about joysticks. And joysticks it's probably not the definition that you have in your head when you think of joysticks. But joysticks are the main way drivers control a robot. So our team has one driver, one or two. I think we have one driver and one operator. And what the driver uses is, on our team, they use an Xbox style controller. So it looks a little something like this, right? But other teams can use other methods. For now, just know that we use an Xbox controller, right? And each part of the joystick, so in this case, throughout this entire presentation, when we talk about joysticks, we're mainly talking about the controller itself, not these little like joysticks here. I have a different name for them, which I'll go over in a second, just to make it a little less confusing for you guys. So we kind of like code for a certain part of the robot, and then we bind that code to a certain button. So what we're essentially doing, what bind basically means is we're setting the code to a certain button. So let's say we want a code that kind of shoots a ball. We're gonna bind that to a button. Let's say we want to bind it to B, right? That means whenever we press B, it'll shoot the ball out with a robot. So joystick basically means controller, like the actual Xbox controller, and it's the way we control our robot. So we're going to start talking a little bit more about the code now. In order to code for a joystick, the first thing we needed to do was import the joystick class, which is what we just did. So we're good on that, right? After we've imported it now, we can make an instance of it, or we have to make an instance of it in order to use its methods. So by instance, we mean object. So in the review earlier, I talked about objects, which is basically making an object of a class. That's kind of what we do in our code. So for the joystick class, we make an object of that joystick. So object instance are the same words. They essentially mean the same thing. So again, we're going to refer to our API in this. Like I said, it's documentation. So anything you don't know about a robot part, just refer to the API and you can usually find it. So we're kind of going to go here and I'll show you where to find the constructor, right? It's kind of labeled for you, right? Up here, constructor. And then you can kind of recognize this as method, right? So if you need a method of this class, you can always go here, but we'll talk about that in a second. So right now we're on the constructor part. And remember, a constructor is used to create an object. Like the reason we have that in our class is to allow us and help us create an object of that class or an instance of that class. So this portion here is essentially the picture that you see over here, right? The way we make an instance of this class is the same thing, right? It's just telling us what parameter we need in order to make it, right? So using our API, how would we instantiate a joystick called ATK joy at port 3, right? The way we would do that is the same way we would make an object. Remember, it was class name, object name equals new class name. And then inside the parentheses, we would put a parameter. And then at the end, always have a semicolon. So this is kind of the same thing, right? We're going to use the API. So using the API, we know that we need to enter a port number, right? And that's given to us in our question, right? So port, we'll kind of start from this beginning, actually. So the class name is joystick, where the object name is basically the name that we want to call the joystick, right? So in this case, we're calling it ATK joy. So the object name is ATK joy, and we're setting it equal to this. So we're saying new, which is what we need in every object. When we always make an object, we always say new, and then the class name again, and then our parameter. And for a parameter, they want the port number. And it's given to us in our question that we want to set it at port 3. So it's joystick, ATK joy equals new joystick 3. right? So remember that this joystick class is the controller itself. It's not like the thumb sticks that you have on your controller. It's an actual Xbox controller that we're coding for. That's what we refer to as joystick. Okay, moving on. So now that we've imported the joystick class, we've made an object of that class. So now we have everything we need to kind of call the methods and use it throughout our code. Right, so we have our joystick class, and we can see that there's a method called getRawAxis, right? And basically what this method does is that it gets us the position of the joystick. So the joystick on the controller. So this is where it kind of gets confusing. So for the purposes of this presentation, I'm just going to call it a thumbstick, which I know it sounds really stupid, but it kind of works, right? You control those things with your thumbs, and that's what I'm going to call it, right? So getRawAxis is essentially getting the position of it, of the joystick. Okay, so if you go over here, we can actually kind of look for this method. So I always use Control F, right? So I'll show you where it is, getRawAxis. It's right here. I'm gonna click on it, and then it's gonna load up a kind of like description of what the method does. The method header. So this tells us what it returns, the name of it, and the parameter that we need to input in order to use it. Right, so it's kind of like a documentation, like I keep saying. Same thing as a picture over here. So the way we get the method getRawAxis is that we call it on our object, right? So if I go back here, we created our object, and this is what it's called now. In order to use the method on the object, we have to write the object name dot and then the name of the method that we want to use. So in this case, we're saying getRawAxis. And then we need to put in a parameter, right? So this parameter axis basically means the position of the thumbstick relative to the controller. So what that means is that each button, maybe I can go over what it shows here. Oh no, okay. So each button on our controller is labeled by a number, right? So I think maybe in our robotics code, we actually use 1 and 5 as numbers. So this thumbstick here is designated as number 1 or axis 1. And then this one here is designated as axis 5, right? So this code here is essentially getting the position of the joystick of this thumbstick here. It's getting the position of this thumbstick here because we're saying that the axis is 1. Right, but if we wanted to get the position of this thumbstick here, we would say atkjoy.getRawAxis5 instead, right? So it kind of means two different things. And by position, I kind of mean, like, you know how on a controller, you kind of move the thumbstick up and down and left and right? That's kind of what it's doing. And I think it's going to return a double, right? And it's kind of going to return the position of it relative. So if it's all the way up, if it's like centered, I think that's 0. If it's all the way up, it means 1, maybe 1.0. And then if it's all the way down, it means negative 1.0. But you're gonna have to check me on that because I'm not entirely sure. So the joystick part is probably the most confusing part of this entire code. Just because like joystick refers to controller, and then thumbstick refers to like probably the joystick that you actually think of, the joystick on the controller. Yeah, so just kind of look over this for a little while to hopefully get it in the end. And now we're going to move on. So now we're going to talk about speed controllers. So the way our robot moves is on motors, right? So the motors kind of turn the wheels, and that's how it allows us to move our robot forward or backward, stuff like that, right? But we can't like specifically code for the motors. We need to code for whatever controls the motors because the motors can't run our code. So we call these speed controllers. Speed controllers allow us to set the motor speed to a value. So essentially, they're controlling the speed of the motor, right? So if its value, okay, so the speed controllers essentially allow us to control the motor speed, and we can set it a value from -1, which means it's going backwards, to +1.0, which means it's going forward. Right, so that means we can set it to any value in between those values and including -1 and 1. So this helps us determine the speed and the direction that it's going to go. Right, so yeah, it's just forward, backward, and then high speed and low speed, I guess, kind of like that. So these are controlling our motors. Remember, they're not specifically our motors, they're controlling our motors. We typically use spark maxes, which is the name of the speed controller that we use, to control the motors that the engineering department uses. So the motors that the engineering department typically use are called NEOs, and then the speed controllers that they use are called spark maxes. So I think they're gonna show a picture right here. So this is the spark max, aka the speed controller, controls this motor. So it's probably not what you pictured, at least it wasn't for me when I first saw these pictures, but yeah, you can kind of help you visualize a little bit what we're talking about. This is the motor here, this is the speed controller here. Okay, so how do we code for those speed controllers, right? The first thing we need to do is import it. We always need to import it. And then we have to make an instance of it to use the method. Instance meaning object, same thing, they're kind of interchangeable. Right, so the steps for coding this type of stuff is import, then we make an instance or an object of that class, then we call whatever methods we need. So I'll kind of show you this API too. So this is actually a different company, I would say, than this one. So this one is FIRST specific, right? So in robotics, the competition that we participate in is FIRST. FIRST stands for a bunch of stuff. But this one here is Rev Robotics. So we use two different APIs. Well, we use more than two, but these are the main two that we use. And this is the CAN Spark Max API, right? So you see the class name up here, the import statement, which is what we need to import. So we always type import, and then we type this highlighted statement here. And then if we scroll down a little bit, we can see the constructor, which is how we make our Spark Max controller, right? So this is kind of like a guide on what parameters we need to give this object, or give to make the object. And then the method summary, which is down here. So we'll kind of go through it again. So how would we instantiate a speed controller for the front left motor at port 3? Right, so this question is kind of loaded, but if you break it down into small parts, you'll be able to understand what it means. Right, so I'll show you guys the answer right now. So remember how in order to make an object, class name, object name equals new class name, and then the parameters inside if needed, right? So we have our class name here, can spark max, which is same thing here. And you can also see it all the way up here. It says class, can spark max. Right, so we have the class name, and then we have the object name. So since we're using it, we're coding for the front left, the speed controller that controls the front left motor. That's what we're going to call it, front left, right? Mm-hmm. So it doesn't necessarily have to be called front left, but we use that in order to kind of differentiate between each controller, because it's always different, right? If we have a four-wheeled robot, there's going to be front left, front right, back, or rear right and rear left. And that's like a lot to keep track of. So we kind of just call it front left so that we know specifically that we're coding to control the front left motor. And it's even worse with six like motors or six wheels, because it's kind of a lot more. That's why we always call it by where it is on the robot, so we know like which wheel we're talking about or which motor we're talking about. So that's our name. Equals new, which is what we always need when we make objects, right? And then we repeat the class name again, and in the parentheses we just fill in this info here. So the device ID is essentially the port number that we want to input. So we're going to say port 3 because that's what's given to us here, port 3. So port 3 goes in here, and then the motor type. So I'm kind of not going to get into this now because it kind of describes the motor itself and the motor type, but we're not really engineering. So we use motor type.kbrushless. That's what you need to put here. But the way you can actually find this here, if you're unsure, we can go here. So we're in the Spark Max class again. We scroll down, we look at the constructor, and there's options to click, right? So let's say we don't know what to input for the type. We go here, we can click on it, and it gives us the options that we need to use for it, right? So it's right here. We can either use kbrushed or kbrushless. In this case, we want to use kbrushless, so that's what we're going to put down here. So I know it's a lot to take in, especially making objects is kind of really formulaic. but hopefully it gets a little easier for you guys the more you do it, the more you kind of get it. Yeah, so main idea, when in doubt, always check the API. Okay, so I'm not sure how much you guys will be able to answer right now, but for those watching the recording, if we wanted to set the speed of the motor, what method will we use? Right, so what you want to do is you want to go to this API, can spark max, go back here, this API here. It'll be linked in the presentation, so you can kind of just click on it and go to it. Go here, and then you want to find a method that sets the speed, right? So the keyword here is set. So kind of, this is a hint. Just pause the recording now to look for it. Yeah, I'm just gonna go over it now. So the way you want to like look for this method. So in robotics, we kind of like, we don't know every method that we want to use and how we're going to use it, right? We refer to this documentation or this API whenever we need help, right? So let's say I don't know the name of the method. We need to set the motor, the speed of the motor. So I would just go to this API here. I would control and I click set, right? And I'll kind of search through all of this. So look for a method here called set, right? You can use control F if you really don't know, but here, this is the one that we need. Right, and it also provides a description for us, common interface for setting the speed of the speed controller. And that's like literally the definition that we need. So I'm going to click here. Okay, I'm not going to click there. I'm just going to look at it here, set here, right? So we know it's going to return nothing because it's void, but we need, when we call the method, we need to input the speed. And that's essentially what we need to do, right? So the can spark max class shows a method called set that we can use to set the speed of the motor. And this is the method right here. So what we would do is the name of the object dot set, and then we would set the speed. So let's say we want to set all the way at the top, 1.0. That's the highest speed that it can go. So we put 1.0 in the parentheses and then semicolon. Just a kind of bonus information, I guess. We don't typically use 1.0 just because that's way too fast and we don't want anything wrong to happen. Yeah, so we kind of set it a little lower than that. Okay, so this is where it gets a little complicated, but if you break it down, it's easy to read. So we use this method in tandem with the method we looked at from the joystick class, which is getting the raw axis, right? Remember, this method here gets the position of the thumbstick. I'm going to call them thumbsticks because joystick refers to controller, thumbstick refers to the actual joystick on the controller. Right, so get raw axis is essentially getting the position of the thumbstick. So like when we move it all the way up, the position is going to be 1.0. When we move it all the way down, the position is going to be negative 1.0, stuff like that. So we call the object name, which in this case, we're calling the front left speed controller, right? Because that's the one that we want. So we're calling the object name. We're saying dot set, which is the method name. And then we're gonna get whatever is returned to us here. So hopefully this breaks it down for you guys. I'll give you a little chance to look at it. So essentially what this is doing is that we're saying, like, while we're driving, if I push the thumbstick all the way to the top, then I want whatever number that returns to set the speed, right? So I guess like when you're playing a game with an Xbox controller, like sometimes you can walk faster by going all the way forward. But if you go like halfway from the middle to the top, it kind of walks a little slower. That's essentially what this is doing, right? It's controlling the speed based on the position of our thumbstick. Yeah, hopefully that makes a little sense. So, but in theory, it's the same exact way that you call a method. You're just calling the method on the object. You're saying the object name dot set, and then you're putting the parameter. Right, remember that this returns a double, so it works, like it's legal. Like this is how we code for it, because this will return a double number, and that double will be inputted in the set, and that'll set the speed. But if it makes it easier for you, let's say we wanted to set this motor controller to a speed of 0.8. So all we would need to do is say front left dot set parentheses, and in the parentheses we just say 0.8. And that's it. That's how we set the speed. So this is a little complicated, but it essentially means the same thing. Okay, I'm just gonna check the time. Okay. Cool. And now I'm gonna pass it on to Catherine.
I can share screen for this part. Okay, cool. So after talking about motors and joysticks, we're gonna go on to solenoids. So just like motors, we can't directly control pistons, and pistons are things that just like extend and retract. So we'll need some solenoids to control them. So here is a quick diagram. So this would be the solenoid, and it would control the piston, and this thing just goes like in and out basically. Okay, so how do we make a solenoid? So like we talked about before, of course, we're gonna import our double solenoid, and we have our API here, so that can help us. So we'll import this, and then we'll be able to use the solenoid and instantiate it. So how do we instantiate a double solenoid at ports 5 and 6 called shift? So whoever is here or watching the recording, just pause the video and try to do this. Okay, so to do this, we would first call the class double solenoid, and then put the name of the double solenoid, right? So in this case, it would be shift, but sometimes in our code, we do like just like solenoid or something like that. And we need the equal sign, we need the keyword new, and then double solenoid, which is the class name, and the ports 5 and 6. And just realize that for double solenoid, we need two like numbers inside of the parameters. So we have 5 and 6. Okay, so continuing, like the speed controller, the double solenoid class has methods that we're going to be using. So one of the most important ones is called set. So in a speed controller, you're setting the speed, but for like a piston that goes like in and out, we want to set whether it's like retracted or like contracted. I don't really know the names for it, but if we want it to go forward, then we're going to use the value double solenoid dot value k forward, and this just means we want to set the solenoid forward. So following this pattern, what do you think we should write if we want to retract the piston? So you can pause the video and try this. So here's the answer. So we will do basically the same thing, but the only difference is that we're going to set the value to k reverse instead of k forward. So all of this can be found on the API. So if you just look around, we can look for the set class, right? I mean, it's already here as well, but it takes in double solenoid dot value and a value, and this value will be k forward or k reverse. I think there's only two, so okay. So the next one,
wait,
yes.
Real quick. If you haven't noticed already, solenoid is the same as we use double solenoid. So we know we call it solenoid, but in the API we search for double solenoid and not just one solenoid.
Yeah, there's kind of actually a difference. Like there is a one solenoid, but we just found that using a double solenoid is just better for our engineering people and for a robot. So just make sure that whenever we refer to the solenoid, just like know that's double solenoid. Okay, so the next thing would be an encoder. So basically all those other things are like controlling how like the robot would move, but an encoder is kind of actually a sensor that measures how much a motor has spun. So basically like it measures a certain distance that we have traveled. So that is basically what an encoder is. It's a magnet or something else in it that counts the number of ticks that we can use to find the distance that the motor has traveled. So by number of ticks, we just mean like the encoder itself, the way it's built is that there's like ticks, and then like based on how much like you rotate, it counts the number of ticks that it goes through. And it converts that to like a certain distance that we can use. So the speed controller that we're using, which is SparkMax controller, the encoders are actually built in, which means that we will instantiate the encoders a little bit differently, different than like what we've been doing. So here we can see the API, what it says about the CAN encoder. Because it's part of the speech controller, we're going to do it a little different, but we still need to import that class to be able to like instantiate and use it. So if we want to make an encoder for the front left motor, we're going to write this. So this is the class, right? CAN encoder, and we're just going to name it front left encoder, just so we know like which motor we're getting the encoder from, just like so that we know. So this is front left is one of the speed controller instances for like the front left motor or wheel. And all we have to do is use a method called getEncoder, and that will help us instantiate that encoder. So just remember that when you're making an encoder, it's a little bit different. So you don't need the new class and then like parameters. This is all you have to do. Okay, so the next thing is one of the most important methods that we will use for the encoder. So we talked about like what an encoder does, right? So it like gets the distance of like how much you traveled. So this method will basically do that for us. So after instantiating it, you can look at the API, which will be in the Rev Robotics API instead of the first API because it's a part of the motor. And so you can find, well, here, get position, right? So it just gets the position of the motor, basically like the distance. And so you can try to answer this question, how do we call this method on the front left encoder? It's pretty similar to how we've been doing it before. So if you want to, you can pause the video or try it on your own. And I'll give like a second. Okay, so here's the answer. Should be pretty obvious, but like you just call the name of your encoder, which we made in the previous slide, front left encoder. And all you have to do is do dot get position with parentheses. So this method doesn't need any like parameters. So you could just call it with the parentheses and semicolon. And usually we would set this to like a variable so we can store the distance in some way or like compare or do something with it. But this is how we use the method. Okay, so that was all of the robot parts that we're going to talk about today. So now we will look at something called commands. So what is a command, right? So this is the import or like where it is on the first API. So you can always like try to search it up on your own and look at other parts of a command. So what a command is we will use it to set commands to a part of our joystick, such as like a button. So we talked about kind of like binding a button to maybe a certain action. So like pretend if you want to press a button and you want to do something once you press the button. So we will use commands for that. Because once the button is pressed, we want it to run a certain command. So for this is an example, if we want to make the robot shoot a ball when we press a button, you will bind that command to the button. Yeah. And once you press it, that action should take place. So here is the structure of a command. It looks complicated, but we can start to break it down. So just know that a command is basically a class, but it's like more special than just a class because of this like extends command part. You don't really need to know it too much. Just know like this is the structure of a command. So the first thing, like in every class, you need the field variables and you need the constructor, but we won't really have much in the constructor for this command or this class. So in a command, we will use protected void initialize. So this is the first part, and initialize is the like kind of method that runs when the command is first executed, and it's just like initialize all your variables and stuff. And the next part is actually the most important part. It's the execute method. So basically, this method is repeatedly called like in a loop almost until it's finished. And there is this other method called is finished. And the command is finished when this method returns true. So this command, when you call it, it'll go through execute, and then it will always check is finished. And whenever is finished is false, it'll just keep executing like in a loop, basically. Think of it almost like as a while loop. And then until for some reason is finished returns true, then execute will like stop. And then it'll go to the end method, and that will be the final action or the thing that happens at the end of execute. And interrupted is just maybe kind of like a safety kind of thing, and it runs when the command is maybe like interrupted in some way. So that's just what the overall structure of a command is. And we do have like a bunch of commands, right? But each command can only do one thing, basically. So like, oh, you want to shoot a ball, then you want one command for shooting the ball. Maybe you want to like turn, then we want a command for turning. But what if we want to turn and then shoot the ball, right? Maybe we don't want to like bind that to a button, and maybe we want it just to happen like automatically. So this is where command groups come in. So a command group is a group of commands that make up a set of steps. So like I said, like we want to turn and then shoot a ball. So those are like a series of steps that we want to take place. And a command can be added sequentially, so like one after the other, or in parallel, so at the same time with one another. So for example, like in the turning shooting example, if it was sequential, it would mean that I want to turn first and then I want to shoot the ball. But if it's in parallel, you're kind of like turning and shooting at the same time, which is probably not ideal, but you could technically do that. So that's just a definition of sequential and parallel. And we usually use command groups to control the robot autonomously. So in our competition, there's always an autonomous period where we can't control the robot with like a joystick. So we would use command groups to tell the robot to do a certain series of steps on their own, basically. And we don't need to be able to control it, because once we call the command group, then it'll probably just run on its own. Okay, so this is an example command group. It's not the full command group, but it's a part of it that I took from the code that we have. So it is also a class. So just like be aware that these are classes, and all of this is happening inside the constructor. So remember when I just talked about like sequential or parallel? So this is where this comes in. So add sequential means like, okay, you're adding this command sequentially to like the next command. So this means, so imagine that like you wrote the drive straight distance command already, and it has like a parameter and everything. And basically you're saying add sequential with parentheses, and then new drive straight distance with its parameter. So you have to have the new, because you're going to make an instance of that command. And remember that commands are classes. So you're going to make an instance of that command or that class, or like an object. They're both like the same thing. So that's why you have to have the new there. But basically you're just adding these commands sequentially, and then you have a parallel one. So add parallel means that these two commands will happen at the same time. And then you're doing add sequential again, so that these will happen one after the other. So this is like an example of a command group. And it's like the example code for auton or autonomous code that we use for a robot in competitions. So hopefully just like look at this, try to understand what's going on. Just know that these are all commands and parameters, so you don't have to worry about it too much. But yeah. Okay, so in summary, today we learned about the RoboRio, which is the brain of the robot. We use it to load and run our code. Joysticks, which are like the controller, but then we have also thumbsticks that we use to like control the motors and stuff. And then speed controllers are what we code to control the motors. Solenoids are the things that we code to control the pistons, which is like in and out, like things that just go in and out. And encoders are a part of our motors, and they measure distance. And we talked about commands and command groups, which are just classes, like special classes that we use to carry out actions. So if you guys have any questions, you guys can ask them now. But yeah, this is the end of the meeting. Make sure to ask us any questions, email us, or ask us in Discord.
So for everyone watching the recording, I'm just gonna end it now. So if you have any questions, just email us or ask us on Discord. Thanks for watching.